Hello everyone. So today we are going to work on NPC dragon characters. So here is the demonstration. So these blockers I have placed to show that these dragons are not colliding, like they do avoid the blocking structures and fly. I don't have much blockers in the sky, but still they can detect and avoid any obstacles. So yeah, this is my dragon and those are NPC dragons. They can randomly roam in the sky or in the ground. So yeah, this is what we are going to work on today. Let's go closer to one of these NPC dragons. And this the length of the dragon is customizable because this is a procedural dragon. So as we eat those boxes, if you remember, the dragons get longer. Let me go down. No, okay, let's see how to implement these NPC dragon characters today. Alright, so this is what we have implemented so far. We have our dragon character. We can eat boxes to get longer, and we can fly. So yeah, this is what we have implemented so far. So next thing I want to do is implementing an AI system which allows AI controlled NPC NPC dragons that randomly roam in the sky. So at the moment, so it's just this dragon, and it has to be controlled by a player. So I'll create a child blueprint. I'll name it. Now I think it's better to rename this as dragon because it can fly, not just on the ground. Previously it was only it can only move on the ground, so that's why I named it as a snake. Okay, let me fix up redirectors. Right, now let's create a child blueprint. CH dragon NPC. Okay. Okay, now let me place an NPC dragon here as well. I'll set the body count to 50, and maybe we should the blueprint. We should change the color so we can easily distinguish. That's not actually not a big deal, but let's just do it. This is the color we have, material we have. Let me rename as color, and create a material instance. Blue. Okay, let's assign that color for the ISM2. Right, now the NPC dragon is blue. maybe not a good idea because the sky is also blue, but yeah, we'll see. So okay, so to implement fly, I'll add an event. I'll call it NPC move, or just moment. So here for now I'll add moment input in the forward direction at forward vector. So let me disable processing of these player dragon so we can just look at it. Oh wait, I'll set the game mode also to this game mode. Do we have a player start? Yeah, we do. Let me delete that, but I forgot to call this from anywhere. So here I'll call NPC movement. Now you see the dragon is moving. Just forward. Okay. Now, what if there is some object like this? So at the moment, it cannot determine if there is object or it just gets stuck. That's what happens. So I don't really want to utilize things like nav measures. So yeah, any navigation stuff that is already available for AI characters in Unreal, because this is sort of not exactly ground movement. This is going to be air movement, so I'll just keep it simple. So let's go here and do a line trace by channel. Let's use visibility. Starting point is get actor location and endpoint is get actor forward vector, some point in front of the character basically. So get the actor forward vector multiplied by, let's multiply it, convert to a float. I think looking up to how much, 500 units should be enough, but if not we can change it. So that's the end. Okay, so now I'll change this one. So I'll add a new vector. Let's promote this to a variable. I'll call it moment direction, because we are going to change it. By default, the moment direction should be, well, we don't need to set it just yet. So I'll promote this part to macro, because we gonna have to do multiple line traces. Trace M. Right, now here I'll change this input to direction, and if this is not blocking, so let's have a branch. If this is true, that means blocking. If this is false, that means not blocking. So we need two outputs. So I'll call this non-blocking, blocking. And also we need to return the direction as well. Wait, not necessarily. If it is non-blocking, we can simply set the direction before returning with this given direction, because this direction is not blocking. So what that means is we can actually take that direction. We can actually go to that direction. That's the meaning of it. So right, so here, oh sorry, if it is non-blocking, yes, we can take this path. If it is blocking, we can either try to go up, down, left or right. So first let's consider up. So get actor up vector. If it is non-blocking, we can go upward. Right, now let's see what happens. Yeah, right. If this is way too high, we have to change the way we change the direction the dragon is looking. By the direction I mean look up, look up, look up, look down part. So similarly, let's implement, if it is blocking, let's do another one of these. This time let's make it go to right. Get actor right vector. And if that is also blocking, let's make the actor go to left. Get actor right vector multiply by -1 to get the left vector. Also we forgot about moving down. So to make it move down, do we have a get actor left, no, get actor down, no, okay. Multiply with the float -1, give the direction. Right, if not plug in we can move, otherwise we can't move. Okay, now what if we give preference to left and right rather than going up and down? I think that would be better. Yeah, okay. Now I can actually make something that it's truly blocking a bit more challenging. What if we make something like, yeah, it can still take the turn even though yeah, it's fine. What if we do something like this? Yeah. Great. Okay, now this is a bit boring. You may think, because if there is nothing blocking, it's not random, the dragon is just moving forward. That's basically what happens. So to make it a bit more interesting, we can do something like this. Now let's add another vector turning. Let's just say turning amount. Oh, M is also capital. Let me make it simple. And this also has to be a vector. Now to make the moment random, here shall we collapse this? Not necessary. Get more space. Get another trace M. So first what I'm gonna do is trace this. The rest should come down. If it is blocking, we should try the forward direction first. So yeah, the direction is not forward. Forward plus the turning amount. Like this. And by default, turning amount is 0, so you wouldn't see any difference. See? Nothing. So now what I'm gonna do is I'll add a custom event, another custom event. Let me add it here. Random turn. So here I'll set turn in amount with some random value. And it has to be not too drastic. So I'll create a random floating range. So in between maybe -3 and +3. I think if I connect the same pin here, it would return the same, make the same value, which is not good. So I'll duplicate this. And add it. And after setting the random turn, setting the turn-in amount, I'll have another random delay. This also has to be random. So random float in range, something in between 5 and 10. Sorry, I forgot to call random turn. I need to call it here, random turn, in the begin play. To see where it is trying to move, we can enable debug type for a duration. Okay, I think it's trying to move down. That's why this down line traces are there. It's constantly trying to move down. Okay, why is that? Hold on. When we do this addition, this is not a directional vector anymore. So I have to do a normalization here. But still that wouldn't solve that problem we had. Oh yeah, now it's actually moving upward. Wait, isn't it changing the direction? Sorry, I need to call random turn again. Otherwise, the direction will not be changed. Randomly. Okay. Now it's going that way. Okay, one more problem is the head is always horizontal. We need to fix that. It doesn't look good. So we set the head direction actually in the parent. Here, align head. Right, so I think we should think of a better way to do that now. So what I'm doing is I'm just setting the head rotation based on the input direction, based on this fly input. Instead of doing that, if I get actor get velocity and consider the z component of the velocity, I think that should also give us the same result. Yeah. Wait, hold on a second. That's bad. It was okay for the player character, but not good here. So, alright, we can do something like this. We can get velocity again and get vector length no, just length, vector length, right? And if we divide this value from the vector length, so this cannot be 0, otherwise it would be a problem. So maybe instead of clamping, I'll make sure it's not 0. So this has to be larger than 0. And multiply this value with let's say 60. No, maybe 90. Yeah, 90, and assign it as this value. Assign it as the 𝐿𝐵𝐻 value, which should go here. Oh, it's looking down. Alright, we need to multiply this with minus 90 because roll is inverted. In order to look down, it should be positive. Look up, it should be negative. It's trying to move down, so that's why it's going horizontal. Now it's moving up slightly, but yeah, now I think head is working correctly. Yes. Much better. Let's test the player character as well. Processing enable. See, now when we go up, it actually looks up. And when we move down, the character looks down, which looks natural. So the head turning method works for the player character as well. Nice. Now one more thing. Let me disable the line trace debug type. And let me add 3 more dragons. Nice. Okay, so that's it. I'm gonna stop this episode right here. So thanks for watching. As always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.